Okay, this is chapter 3, questions 7 and 8. 7 is the element M forms the chloride MCl4 containing 75% Cl by mass. What is the atomic weight of M? Okay, so we got M unknown, little question mark right here. Cl, you can look it up on the periodic table, 35.45. But we got 4 chlorides, so we just multiply that by 4. And that gives us 141.8. Okay, so they give us 75%, and percentage can always be written as 75 over 100 equals 141.8, okay, over the total mass, which is MCl4. But because I don't know M, I'm just going to put an X right there because I don't know what the total mass is. So here we just solve like a regular ratio, 75x, okay, equals 100 times 141.8. So that should give us 14,180. Okay, so now that we know these two, we can solve for x, simply dividing 14,180 over 75. 14. And we get, okay, I'm just going to erase this part right here so I can have space. We get x equals 189.067. Okay, so remember, this is the total mass of MCl4. So MCl4 equals 189.067. That's a weird 8. It's cool. Now, the good thing about this is we already know what Cl4 is. So if we subtract Cl4, which is 141.8, watch what happens. Right here. Remember, this is me subtracting Cl4. I'm left with M. So now all we got to do is subtract 141.8 from 189.067. And M is equal to 47.267. But our answer, we can round this up, 47.3. 47.3. This is grams per mole. Okay. Number 2, combustion analysis of morphine. Oh, that's right, I forgot. 20, let me just make sure, 22. Okay, 22 milligrams of morphine produced 13.2 milligrams of H2O. What is the percentage by mass of hydrogen in morphine? Okay, so first of all, if you remember from the other video, we were exclusively or just using grams. But here in this problem, they give us milligrams just to throw us off. If we want, we have to, or if we want to find the answer, we first have to change the milligrams to grams. So we can start off by putting 13.2 milligrams of H2O over 1. And then we're going to do, well, how many milligrams are in a gram? We're going to put 1 gram, because that's what we want at the top. At the bottom, we're going to get whatever we cancel out, so milligrams. So in 1 gram, there's actually 1,000 milligrams. So here, mg over mg cancel out, and we're left with 13.2 over 1,000 grams of H2O. Now, because we got a little bit of space over here, and there's another step after what I'm about to do, I'm going to try to do all of this in one big old procedure. So we go from milligrams to grams, and now we can go from grams to moles, because we want to find the mass of hydrogen, but we can't just make a ratio with the weights of mass, with the weight of hydrogen and water. First, I have to go to mole. So I'm at 1 gram H2O, almost forgot H2O, and now I have to go to the mole. So remember, my grams have to be at the bottom, and my mole is going to have to be at the top. So 1 mole of H2O weighs how much? Well, hydrogen is 1.008, oxygen is 15.99. So all we have to do is figure out the total mass of H2O. Don't forget, there are 2 hydrogens, 2H. So you got to do that 1.008 times 2 plus 15.9993, and that should give you 18.015 grams of H2O. And now you cancel out the grams, and now we're at mole. But remember, we want the mass of hydrogen, so we got to go to mole of hydrogen. So for every mole of H2O, well, how many moles of hydrogen do we have? We got 2H. So 2 moles of hydrogen for every mole of hydrogen. Water for every mole of water, sorry. Okay, so now we cancel out mole of H2O, mole of H2O. Finally, we're at moles of hydrogen. And our final step in finding the mass of hydrogen would be to multiply times our mass of hydrogen and cancel out our moles. So we have to multiply, one more time, like I said, our mass of hydrogen, which is 1.008 grams of hydrogen, and divide by the mole. So 1.008 is for 1 mole of hydrogen. So here, mole of hydrogen cancels out, and we're at grams again. So now we can do this process. 13.2 divided by 1,000. It's going to be a real small number, but bear with me. It's going to be 0.0132. And then we're dividing again by 18.015. 18.015. Then over here, 2 over 1 is just 2. So we multiply by 2. Okay. And at the end, we've got 1.008 over 1. So we just multiply times 1.008. Okay, so after all this, after you put all this in a calculator, what you're going to do is end up with 0.001477 grams of hydrogen. Okay, so finally, we found the mass of hydrogen, which is what we've been, after all, looking for. But, dang, that's a really, really small amount of hydrogen. That's because, remember, we started off with milligrams. So we want to go back to those milligrams. What we do is we do the opposite of dividing over 1,000. So now we take our 0.001477 grams of hydrogen, and we multiply times 1,000 milligrams of hydrogen over 1 gram. So here, grams cancel out. We end up with milligrams. We end up with 1.477 milligrams of hydrogen. Okay, so we got milligrams of hydrogen, we got milligrams of morphine. Now we can actually find what we want to look for, percentage by mass, percentage. So we put over here 1.477 over 22. Okay, so mass of hydrogen over the total mass of morphine, which is 22 milligrams, should give us a decimal. Okay, to turn this decimal into a percentage, all you have to do is multiply times 100. Okay, so from this 1.477 over 22, you should get 0.067. But remember, we're multiplying this times 100, so you can find your percentage. And it will give you 6.71% or 6.7%. Mass of hydrogen. So 6.7 is your answer on number 8, and 47.3 is your answer on number 7. Okay.